Hello everyone. Today in this video we'll be discussing about bytes array and memory view. So these are data types in Python, and these are basically used for handling bytes data. So if you think of one byte, it is actually 8 bits, okay? And within 8 bits we can adjust numbers from 0 to 255. So we'll be seeing like all the things, like how to convert it into bytes. And here if we observe, all the numbers should be within the range of 0 to 255. And sometimes we'll be converting some strings also to bytes, and then you might be thinking, then where are the numbers over here? Actually these characters will be having the corresponding ASCII number, so it will be taking that ASCII number into consideration, and ASCII values will be in the range of 0 to 128, and if it is UTF-8 is also extended ASCII, so there you will be having from 0 to 255. Okay, so these are within the range only, that's why we can directly use these strings. So let's see like how to use these bytes and bytes array. And if you see the difference between bytes and bytes array, bytes is immutable, whereas bytes array is mutable. So I'll not be going into detail like how bytes is used and how bytes array used separately. I'll be discussing about bytes in detail, and I'll be just telling you how it is changed in case of bytes array. Okay, so let's see. So initially I am initializing a list. In the list we are having 1 2 35 and 4, and here if we see, in all these things I'm not using anything which is crossing 255. And let's see if we make anything cross 255 also. So let's execute this for now, and let's see the list. Now the list got changed into bytes, and if we directly print the list, it is showing something like this. You might be thinking what it is. Actually these are the hexadecimal values. Like for 1, this is the hex value, and 01, and 2, this is the hex value 02, and for 4, this is the hex value 04. Then you might be thinking, what is this hash? This hash is corresponding ASCII symbol for 35, and like for every number there will be some ASCII symbol, and that ASCII symbol is printable, then it will be directly printing it over here. If it is not printable, then it will be showing its corresponding number like this in hexadecimal format. And let's change it to some 256. Okay, then it should be giving us error, because we have discussed that it will be accepting the range of 0 to 256, sorry, 255. So I didn't execute this, sorry. So now it is giving us error. Okay, so it will be accepting in the range of 0 to 255 only. So if we give 255, then it will accept. So see, it is accepting. So, and on these also we can index, and we can use methods of, like here we can use in bytes and bytes array, we can use all the methods of string. Okay, let's see the string methods. Here if you see, we have center method, count method. All these methods can be used. Ends with, find, like is identifier, strip. All these methods can be used within these bytes array as well. Okay, and let's see, if you wanted to convert any string to bytes, then you can give it like this, and it is giving us error. Basically it will be accepting some encoding technique. So in encoding we can pass ASCII or even UTF-8. UTF-8 will be having range from 0 to 255, whereas ASCII it will be between 0 and 127. So it's better to go for UTF-8, so that for every number you will be having some encoding. Okay, so here if you see, it is printing hello. Basically we are taking a string. This string, it will be seen as stream of integers, and each integer is of corresponding ASCII value will be present, or UTF-8 value. So those values will be converted like this, and it will be shown like this. And similarly, if you wanted to decode a string that is converted into bytes, then you can use this function decode. Now we will be getting the actual string, that is hello, And similarly, you can convert some tuple to bytes as well. And as I said, you can use all the functions within string. So the count is one function in string, and in this tuple, if you wanted to count like 90, then you can count that, and it is showing us one time it is present. And let's see. So here, if you see 90 is only present once, that's why it is giving one. And if it is present two times, it will be giving us two. And we can, like, anytime any iterable object can be accessed using these indexes in within these bytes. And similarly, even range you can take. Okay, so range will be obviously continuous, and here I am passing range 20. That's why range with 0 will be 0 and range 5 will be 5. Okay, and if I print this range, it is giving all these values. If you observe here, it is 0, 1, 2, 3, and for 9 it is showing this /t. That means that tab, and this is new line. So these are the corresponding ASCII symbols, and these can be printed. That's why it is showing it directly. And remaining wherever there is hash like hex value directly, that means those cannot be printed. That's why it is showing like that. Okay, and similarly we can convert some set, and you might be thinking it will give raised error because set can't be indexed, but we are converting into bytes, and bytes can be indexed. Okay, that's why it will not be giving us any error. And similarly, frozen set also can be converted to bytes. Okay, and dictionary can also be converted into bytes, but this bytes function will only consider the keys. It will not consider the whole items, because in dictionary they will be having key value pairs, so it will not be considering all those things. It will only be considering the key values. Okay, so this U02 and tab. So if you observe here, corresponding ASCII values are present. 85 is the ASCII value of capital letter U. Similarly, for 2 is represented using 02. Its symbol is something that can't be printed. That's why it is showing like this. And similarly, 9 is printable. That's why it is showing /t over here. Yeah. So if you observe it like that, and you can index this like this also. So we are getting the corresponding index values as well. And similarly, you can pass some integer value, but what this bytes will do is, if we are passing some integer value, those many stream of bytes will be getting, and each byte will be filled with 0. Let's see. So if we see over here, we are getting how many int value is how much. We are passing 78. So these will be 78 number of zeros, and each is represented with hex value, and these are all these were of 8 bits. Okay, that means 1 byte. And similarly, float, let's check whether it can be converted or not. We can't convert that because float obviously is not between range of 0 to 255 and all. So we can convert this into int and then pass it to bytes, but we can't directly pass the float like this. It will be giving us error. Similarly, complex also we can't pass, and similarly none as well. Okay, and let's see, if you are passing some range 128, then it will be printing us all the values. Then you will be getting some idea what I am telling. So if you see over here, it is giving 0, 1, 2, 3, 4, 5, all these hex values, and then for 9 it is giving us tab, and for 10 it is giving us new line. And similarly, we will go like this. Here it is printing some symbols 0, 1, 2, 3. We know there is some in range between 47 and something, and 65 to something, and 97 to something. These alphabets letters are present. So let's see. So if we see over here, at 48 we are starting 0 and ending at 57. So this index, if we observe, it will be it is 47 actually. And similarly, these are from 65. Okay, sorry, these will be from 65. So if you observe, it will be 65, and it will be ending at somewhere 90, and these will start at 97 and end at where it will end. It will end at 122. Like that, we'll be having all those values. Let's print all the 256 values. Then till this part, it will be the same. After that, it is only just giving the numbers directly. Okay, so these are all the hex values of those corresponding numbers. Okay, and we can we assign like this? Just think of it sometime. We can't assign because bytes is immutable, whereas bytes array is mutable. There we can assign it like this. Okay, so this assigning is possible, whereas here assignment is not possible because it is immutable. Okay. And as I already said, all the string methods uh, were supported for bytes and bytes array as well. Okay, so and the only difference between byte and byte array is byte is immutable, whereas byte array is mutable. Okay, so let's see. So if we wanted to check the type of these, it is showing us bytes. And similarly, let's create a byte array. So instead of byte, we can use this byte array and simple. Just we can use it like this and do all the operations that we have done it on byte. Okay. Now it is showing us byte array. And here we can do this assignment because now it is a byte array and that is mutable. And even in byte array, you can't add some new elements to this corresponding BA tuple because it is not supported. Only the thing that we can do is we can change within the existing elements. We can't add something new to it. Okay. So if you observe here, it got changed. And similarly, let's see the tuple. But tuple is still remaining because it will not be affecting the tuple. It is different, and the tuple is the different one. And similarly, we can get some string into this byte array, and we can change even the string. You might be thinking string is immutable, and similarly tuple is also immutable, but even then we can change those because these were converted into byte array, and byte array is mutable. Okay, so we are changing it to a, and it is not supported because we are directly giving it some character value. So we have to, like when we are indexing like this, we have to pass the integer value. So instead of, we wanted to give a, so we have to be passing the ASCII value. Let's say you don't know the ASCII value, then you can use some function called ORT, which will be giving the corresponding ASCII value. So for a, it will be 97. So that value will be given. So, and similarly, there is a reverse of this ORD function, that is CHR. So if we are providing this ASCII value over here, it will be giving the corresponding character. So for 97 ASCII value, the corresponding character is A. Okay. So if we are passing some character to ORD, it will be giving the corresponding ASCII value. And similarly, if we are giving some integer to CHR, it will be giving us the corresponding ASCII symbol. Okay, that is the difference between this ORD and CHR. And let's see the memory view. Memory view is like some view from outside to the list, and you can change something in using this memory view, and it is not like a copy. It will be pointing to the same address, and we can view that, and also we can make little changes as well. So it is memory efficient, and it will support us like when we are using copy. Let's say copy is very, like it will be taking more memory because we are copying everything into other one and then we are doing, whereas in memory view we'll not be copying anything. We'll just providing some view, and on that view if we make any changes, it will be like available on that, and we can copy it to some other thing. Okay, let's see it over here. So if we see, we are passing bytes list and it is executing. If we directly pass list, it will not be executed. So memory view will be accepting either bytes or bytes array. So we can't pass any other data type to it. Okay, remember this. And similarly, we can use indexing on these memory views. And if you directly, instead of single indexing, if you give multiple indexing, then it will be giving us just the address of it. It will not be giving the values as in here. Like here, if we see, if we give directly, here it is showing all those values. But in case of memory view, if we directly index it, it will be showing us the corresponding value. But if we try to see like some group of values, it will be just giving us the address. And if we convert that address to list or bytes, then we can see those corresponding values. Similarly, string can also be converted to memory view. And if we try to see, we are trying to change something to it, it is not possible because we are seeing memory view to bytes. Okay, and bytes is immutable, whereas if you are seeing on bytes array, then we can do this. Okay, and similarly what we are trying to do, mv is on list and it is also byte, so I prefix it with byte if it is bytes, and if it is bytes array I prefix it with ba. So it is also bytes and it is also immutable, that's why we can't do this indexing. Let's take bytes array of this list and then try to change something. So if we see over here, we are taking bytes array and we are taking the memory view, and then let's change some value and now convert this memory view into list. Then we'll be having these values like 25, 2, 255 and 4. And if we observe the actual list, it is not changing. So this is possible only when we do copy, but even without doing the copy, we are able to achieve this. Okay, so it is memory efficient and faster as well. Okay, in such cases you can use this memory view. And let's see, so let's check the type of this. So if you prefix any string with this b value, that means that it is bytes type, so it is giving us type bytes. And this string, this bytes is immutable, that's why if we create any, like for suppose mv1 is there, let's see what is mv1. mv1 is on this b string and this is on bytes. Bytes is immutable, so if we wanted to check whether can we change those values or not, we don't know whether it is mutable or immutable, then you can use this dot read only. It will be telling it in true or false. So true, that means that you can only read from mv1, and in mv1 what we are having, bytes of a string. Okay, so that's why it is only read only. And similarly mv is having bytes array and it is not read only, we can write as well, that's why it is false. Similarly we are taking bytes array on string, there also if we see read only, it will be false. Okay, I hope you guys understood this concept, and if you have any doubts you can comment down in the comment section. I will be responding to those comments, and I hope you guys enjoyed the video, and thank you.